Pandemics, yeah. So the spreading of the coronavirus, maybe, yeah. Okay.
Like
Property values going up, yep. Transportation, congestion on the roads, right? So it's not all rosy. There's issues that you have to deal with. That's what this next section is going to do, because there is some a balancing act, trade-offs, that we have these benefits being close together, but then we might have some other costs offsetting that as we move along. So we're going to kind of think about that here with this model, starting with an isolated firm. So a firm in isolation, and then what happens if there's agglomeration economies to the positive? What would happen to profits if you joined your isolated firm versus moving somewhere next to another firm where there's agglomeration? What's going to happen to profits? They're going to go up. So they're going to go up for a while, but do they go up forever is kind of what I want to think about now. When will we start to have an issue? So your textbook got rid of this. I actually pulled this out of the old edition because I think it was helpful. So at the top here, we've got the number of firms in a cluster. And so you can kind of think about the lines going different ways. So they had a prop cost for like Hollywood. We talked about Hollywood having scenes and stuff. So as we use more, we've got economies of scale dropping down the cost of that intermediate input. But then labor costs might start to go up if there's more and more competition, like one company's trying to steal them away from another company. How do they do that? They offer them a raise, right? So you're only making 30,000, I can pay you 35. And so maybe labor costs start to be bid up. And so now your total cost of production has two things going on. Some things with advantages from agglomeration, like the prop costs, and then some things maybe increasing eventually because of that. And that leads us to this next panel here of thinking about the profit for the firm. At what point will we want to, start getting out, or will we start seeing firms get bigger and bigger? So we start down here at one company in isolation. And so what would cause there to be a second company or other companies to come? The agglomeration benefits are there. So over that first section, we've got labor cost still being lower than the prop cost, and so it's diminishing. So the total cost curve is coming down right here. So we've got this cost savings coming down, causing our profits to go up. But eventually, we're going to start to run into that situation where the total cost is going to go up. The question is, will companies quit coming in? So here we are at two companies. We moved from B to C. Profits went down. This is total profit of a firm. Remember how we looked at the profits in aggregate of the firms, like the size of the profits? So now we've got three firms, and then in a competitive industry, they're all going to be earning the same profit, roughly, right, if it's a competitive industry. But profits are down. So the question is, will the fourth firm come in? Yes. Will the fourth firm come in? Luke, you say yes. Why?
Because they're still making more than the baseline.
Yeah, the baseline is what we're kind of keeping an eye on. So operating in isolation still doesn't make as much money as operating in the cluster. So when are we going to quit?
When we have 5 people.
Get to 5. And now we're back to the baseline. We're in a equilibrium, Nash equilibrium, if you want to look at it that way. So we're going to have firms continuing to add back until we get to this profit level where firms are indifferent between operating in isolation, operating in the cluster. Okay? Questions on that one? This is the way your book presents it now. They tell the whole story. They just got rid of the pictures. I don't know if they're trying to trim size or what. That do you see? Or what? Outside from the outside? Okay. He's took it in his thing. I'm like, okay. Just gets back from sickness. So the the book kind of talks through this. Here's one company, here's two companies, profits are going up, profits eventually come down for the isolated firm. So then they kind of add to the dialogue the optimal cluster and how we're not getting maybe what would be perfect if there was coordination or cooperation. So if the firms could talk to each other or work together somehow, the optimal cluster size would be that, right? Something short of where this is going on. And so if it's competitive, then we're going to have firms enter till we're here. Or is it possible that multiple clusters could develop? So this is still the equilibrium, but it kind of just brings that up that in theory, the firms could be made better off if there was multiple clusters. Okay. So why cluster? This is kind of a summary of the 4 areas again. So we got intermediate inputs, the props, share the labor pool, better matches, and share knowledge. So the kind of the 2 terms that we started off with at the beginning of the chapter was localization and urbanization. Okay, that's all on previous slides. So now let's look at some data. So this is some clusters that the author identified. Aircraft, engines, so as far as industry, biopharmaceutical, computer software, so of course you got Silicon Valley, like we've talked about, elevators, Bloomington, financial services, of course New York City, Manhattan's kind of the center of the world, and then Hollywood here, video distribution. So what's kind of interesting to think about the clustering is 44% of Hollywood, of film production, and the Oscars were just last night. Did anybody watch that? That was trash. I did. A little bit. Couldn't help it. Even though I haven't seen any, well, that's not true. I saw The Irishman, which was way too long, but I haven't been watching very many movies, but it was all right to have on. So 44% of employment in the filming industry happens in Hollywood. So that's pretty big, right? It's really evidence of this clustering effect. 20% of elevators. Financial services, 13% of the market is in Manhattan. Right? Big cluster when we think about that. Computer software, so we got Seattle, New York, biopharmaceutical, and the aircraft engines. So we start to see the percentage of employment as one way to view the cluster. Then they got these kind of cool 3-dimensional graphs. This one showing the carpets and rugs. So Dalton, Georgia has a big cluster for carpets. Like most of the carpets for the United States come out of there. So 41%. So the height of this stack shows the percentage in different parts of the country. And you can see that they're all kind of clustered together near there. So that's kind of fun. I think I got another one up here too. Costume jewelry. So 4,100 jobs in Providence, a couple in LA, 55% of the industry. Costume jewelry. That was from historically Broadway shows and all of that being over in New York. Okay, so the book just talks about some other more recent studies. So these could start to be areas that you might be interested in for your final project, doing a literature review. So the book's pretty good about having, it's way too early to start talking final project, but I thought I'd point out, they'll have a pretty good reference page at the end of every chapter. So as we go through, you can kind of, you might start in at least the back of your mind. So at the end of, I just picked chapter 11 just to show you. It says references and reading. So a lot of these will be current journal articles and other things that people have done on certain stuff that's in the chapter. So we'll see that as we move along. Okay, what would it mean for knowledge spillovers to be highly localized? Knowledge spillovers are highly localized. What would localized mean?
Like in your little small town.
Yeah, so what does it mean if you're in a small town? The knowledge spillovers are highly localized. Yeah, so if you're in a small town, but you could be in a big town too, and we could have the concept of the knowledge spills being localized. Like, they could be very localized in Kansas City, which is a fairly decent sized city. What would it mean for the spills to be localized?
Live together around certain parts of certain things.
And it's usually physically around something, right? I mean, we can have situations,
cafeteria.
but the benefits of going out to the bar, or you guys mentioning in the cafeteria, like our knowledge spillovers are pretty localized geographically, right? And so that's been some of the studies that this Carlton and Kerr did, is they tried to see, okay, we have these benefits of people grouping together and spillovers of knowledge, blah, 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 it all sounds great. And how much were they able to track that? How far out does it spill? Like, does stuff that go on here spill out all over the nation or not? And it turns out to not. It's fairly highly localized. Yeah.
Now, how is it that knowledge spillovers are more prevalent in industries with small competitive firms? Because I feel like with the book that we're reading, the Edward Glaser book, it talks about in one of the chapters we read, I think it was the first chapter, about like an Indian company that has like very open areas, and I feel like that has like promotes a lot of knowledge spillovers. Or like Google. Google is a huge company, and I feel like their infrastructure promotes a lot of knowledge spillovers.
Yeah, they try to keep it, those spillovers would be localized within their company is what they're trying to encourage, right? So even though they're a big company, they're trying to keep the knowledge spills local there. Here we're talking about the whole industry where we have competitors. And so smaller companies tend to have more multitaskers, whereas in a big corporate setting, you're very specialized. And so I think that's part of the reason why they get maybe a little bit more knowledge spills in that environment. Okay. So this is just rehashing what we just looked at, and then we got more to look at too. So this is just a table showing it a different way. So instead of looking at the pure employment, we can look at the city's total employment. Well, that is the location portion, I guess, for city's total. This is the city's employment, not just the employment of the industry or of that particular company. So the city's total employment as a fraction of national employment is this location quotient. So software, investment banking, it's kind of a rehash of the information we just looked at before, but it does it a little bit different from this location quotient. There's the Hollywood, and one of these has Wichita. So Wichita made the list. Kansas is up there. St. Louis too. So 27% location quotient, but the city's population. So Wichita is full of aerospace products people. Okay. So functional specialization. What the heck does that mean? So functional specialization, what would that be? Let's talk about the function, part of the functional specialization.
Production specialized in a lot of space.
You mean up here?
Yeah.
So they're specialized in production. So what are the functions here? So large cities become managerial functions like what? Yeah, what's a managerial function? Or Zach?
Oh, like a lot of the headquarters for like big companies and stuff in bigger cities, but like the production stuff is how we respond. So like managing companies.
So why would cities have multiple places with mostly managerial functions. So yeah, meeting up at the bar, you've got people of similar functions that would be able to have these knowledge spillovers that would be localized. So that's kind of consistent with what we'd expect if there are benefits of the clustering and knowledge spills, that corporations would just kind of naturally start to do that over time, and they found some results with that larger cities have that. Higher income people or lower income people, most likely in the large cities versus the small cities. Large cities, higher income, they have more disposable income, this all kind of feeds on itself. We want to go to the opera, we want to have things to do, go out to eat, that sort of thing. So as far as being an attractive place to get people for some of those functions as well. All right, last slide, and then we're going to do a few problems here. So, nursery cities. When you think of a nursery city, or what comes to mind with a nursery city, the way the author's got it depicted here? New York, it's a definitely diversified city. They are pretty heavy on financial services, though, if we get into Manhattan anyway. When you say New York, we're usually talking about Manhattan more so than the whole state of New York, which can get into farming communities pretty fast if you guys have traveled to New York. But we usually think of New York City, New York. Yeah, so I don't know if Houston would be a place where I would think of this kind of nurturing environment for early product design. Houston's kind of known to be a little bit of the Wild West in terms of there's a lot of freedom to just build houses, build buildings. They actually didn't have, I don't know if this is still true or if they actually came around, but in later chapters, we're going to get into zoning regulations, and you could put a high-rise next to a trailer park in Houston. It's kind of, that's what I meant by Wild West, like you could do anything. So there's a little more freedom that way. So I don't know if that would necessarily make it a nurturing environment for a startup company necessarily. Although, if you got some wild new idea, maybe that's what you're thinking. Okay. Where else are there a lot of startups? Silicon Valley, exactly. Seattle has a lot too, so those kind of higher tech places. Pittsburgh really changed, and I think that's in our Triumph of the City book too, that Pittsburgh tried to put some infrastructure in of, just having meeting spaces for young entrepreneurs or tech savvy people. So that's kind of what they're getting at here at the Nursery City. Okay, so that's it for that. That's our chapter 4. And pull out a piece of paper. Let's get your juices flowing with a problem here. Yeah, they'll turn this in too. Chapter 4, this is the even problem. You guys are going to do odd as your homework. This is the even problems, or an even problem. We could get one more of these. Not saying we wouldn't ever do an odd, but so switching cost and labor pooling. Consider the model of labor pooling shown in figure 4.2, which I'll put up. As before, the utility function is utility is a function of the wage, is how we read this. My happiness is a function of the wage, and the wage is raised to the 1/2 power. That's just going to give the picture of the utility function that's increasing at a diminishing rate. That was the one we showed before, and I'll put it up again. The isolated wage is 144. So put that down because I'm going to flip the page. So put wage, isolated wage is 144. And the switching cost Yeah.
Five.
So the switching cost is 0. So that was one of the scenarios we did if the switching cost was 0. Suppose the switching cost for the isolated site increases to 80. Illustrate the implications for the expected utility and the certainty equivalent of the isolated job, including the values for both variables. All right, so let me put 4.2 up there. Actually, what I might do is I can switch back and forth and just pull it up on the slide. We did 4.2 in class, by the way. It was a little while ago, so you guys. Okay, that was. This one. So we had the chance, right? And so it was expected utility. So this is our utility curve. We're measuring utility on the vertical axis, income, or it was the wage on the horizontal. So that's the curved line we get from the W raised to the 1/2 power. Again, we don't get into that particular part of the math too much here. So with this one, we had the switching cost. It went from 144 down to 100. And so basically, this question is just tweaking some of those numbers now. So then we walk through what's the expected utility. So in this problem, it was a 50% chance, 50-50 of getting 10 or 12. So we had 11. And then a 50% chance of being fired from either. So we have uncertain utility of 11 comes from a chance of a good or bad outcome. What's the certainty equivalent? And that was our, if the switch cost is 0, you would work for 121. All right, so starting from there, that's your picture. Why don't you guys just draw this picture, I think. Might as well just have this as kind of your starting place. Yeah, I would make it big, yeah. I mean, you don't have to do the whole page, but give yourself some room. That's usually a flaw students make on making things too small.
And it's going to be wage on the bottom, right?
Yeah, it's income, but yeah, income / wage. They just use the W for that.
Give us the divided to the question.
But we're using, yeah, in the question we're asking, sorry, I'll put that back up, but just to kind of switch back real quick here. So basically everything on the first part of the question was what we saw in the picture. 144 up to 12, and the switching cost is 0. Suppose the switching cost for the isolated site increases to 80. Illustrate the implications for expected utility and the certainty equivalent of the isolated job. So that's what we're shooting for.
So what do we put on the y-axis based on that question?
You have a number.
Yeah, it doesn't give us the utility.
Well, you have the formula. So that's how they did this. So what's raised to the 1/2 power? Square root, right?
Oh, okay.
1/2. What's the square root of 100?
10.
Oh. Right. So that formula is this line. We just graphed it out. You guys can work together. So chum up and move tables if you need to, or whatever. It's increasing at a decreasing rate. So whenever here's 3 ways a curve could be increasing. Increasing at a decreasing rate because it's tapering off. Increasing at a constant rate, that's a line, is rise over run, the slope is constant. And then increasing at an increasing rate So all of these are positive functions between, let's say, wage and utility. They're increasing at different rates.
The reason I asked that is because the switch cost here was only one measure. In my mind, I would assume that this one measure.
No, the switch cost is cost you're incurring. So you start with a good job, and then if you have to switch jobs, it costs you. And now it's costing you 80 to rework this problem.
Are we looking for 3 points as well, or just 2?
Same type of analysis that we did before. Oh, you weren't here, I guess. So, so you ultimately the answer is yes. You need to have 3 points to find the certainty equivalent.
There's another one.
Yes. No, it's not a guess. It can be calculated. All these numbers. The square root of 121 is 11. The square root of 144 is 12. So you might end up getting some
Where
fractions.
did they get 121 from? What was that given?
The 121 was just on the function because it was 11. We had the expected utility of 50-50 chance of getting a 12 or a 10. So the weighted average was 11. And then you plug 11 into this formula, which is squaring 11 is 21, solving for the weight.
Do we have to draw those other lines over, or can we put our points on there?
No, yeah, whatever. I mean, you got to make sure I can read it.
Yeah.
Okay, so you're going down to 60. 64 is with the 80. Okay, yeah. So that's kind of your 2 points you want to start with.
I'm thinking it'd be 10 because.
How did we find the expected value of variable x? I gave you guys this in class last time. A random variable x.
P times X.
P times x1, one value of the variable.
Plus 1 minus P times X.
So random variable x can take on this value or this value. Probability P of taking on that value, 1 minus P of taking on that value for a binomial random variable.
Is that times x2 again?
Yep. All this is saying is that this is 20%, this is of course 80%. Right? One of these is 144. So with this problem, we're still following the 50-50 deal.
Right.
Okay. All right. So then where are you going to go from there?
But then I can answer the question. About 3 points.
Yeah, no, that's pretty good. Make sure you answered all the questions. Oh,
Yeah.
yeah, you should be a little cleaner with points and dots just to make sure. But yeah, compare notes with your classmates if you guys are looking. I'm not going to be the answer key here.
1 5 times 1 plus 1 5 times 60.
Yeah, no, you're still right.
Yeah, it should be 104.
So
I don't think mine.
it's just as he said.
Yeah, so that's the other place. Just all over that. Got that equation right here. Solve for W. Here you've got 64.
I don't know, I was just.
Oh, 50%.
Yeah. So that was the old one.
That was not very much. That was not very much.
So now the switch cost is going to be, instead of the switch cost being 44,
Why would
it's
it be
being
10?
50/50.
So that's 144 minus the 80, and then you're kind of following the same.
That's how I would do it.
These are not the same question.
Yeah. Keep going. What are you doing next? So you need to find the expected utility of taking the uncertain job. So when we did it up there, using that random variable, we have a 50-50 shot of getting a 12 or a 50-50 shot of getting a 10, and that's how we got 11. So now do the same thing for your new numbers there.
So this is what I got for the expected. Right.
Expected X, we don't have X.
What do you expected?
That was just a generic formula.
Okay, yeah.
So we're talking W's and U's.
Expected wage then.
Okay.
Expected wage. Would you plug that number into your utility?
No, because the story starts off here with your expected utility. So what is your expected utility if you take the job that you has risk with it? And so we had a possibility of earning 100, and that gave us 10 units of happiness, possibility of getting a 12. So my expected happiness was 11. Yes, so we weren't using this, is what I saw you do. We're doing that, we get 11, and now we can backdoor and say that's the certainty equivalent.
So then, when the number I got for the expected wage, would that be down here and it'd still be 10?
That number is something, but it's not what you want for this problem.
What question of that answer?
Just the way this one's lined up. So what's your certainty equivalent? So illustrate the implications for the expected utility and certainty equivalent of the isolated job, including the values for both variables. So if you've answered that question, you answered this question correctly, or at least you've addressed the right things that we were asking.
So the isolated job is just
So you guys talk amongst each other,
big one and small.
try to get you guys leaning on each other more than me.
We have to label the 7.
Yeah, what's the certainty equivalent? So you need the expected utility and the certainty equivalent. Just like this problem, what was the expected utility? What was the certainty equivalent?
Yeah.
The middle one.
Oh, okay.
You got it?
Right.
You need to read these words really carefully.
I understand. It says uncertain utility.
Uncertain utility, which is your expected utility, you're uncertain about, but it's your expected utility of 11 comes with a chance, but certain income would give you that for sure of 121. So the certainty equivalent income is 121. And then where that story took us then is that the market with agglomeration, it would be better for companies to locate in a cluster because then they would basically get the certainty equivalent and wages would be less.
Yeah, they're gonna forget the 144 and not do the
That's right. They're not going to have to pay the 144 or the 100 and we'll eliminate that risk. Okay, any last questions? Time to move on to the next one. Everybody cool?
Not 100%, but like,
No.
I wasn't here.
So what number, well, yeah, if you weren't here, it's going to take you a little longer because I spent like a bunch of time on this one, right? You spent like a whole bunch of time, right? So you got to keep up on when you miss a class, what are you supposed to do?
Econ restaurants.
Possibly the Rusty Con Rocks, but a better thing to do, ask your classmates, get the notes from somebody. It's on you if you miss a class. You need to kind of catch up with things. Read the book, come in and see me if you got questions, all of that jazz. So, all right. So with the 144, the 80 brought us down to 64, right? And then we had an 8. So our risk was we're either going to get an 8 or a 12. Right. And so then the expected utility between 8 and 12 is a 10. And that gives us the certainty equivalent of 100.
So then would you have the certainty equivalent of 100 also say 10 units, or just be just wage? Just say certainty equivalent of 100?
Yeah, the certainty equivalent would be a wage of 100. And then ultimately, that's what I was saying, the reason why we went through this whole thing is that in a cluster, we'd expect the wages to go down. If there's enough companies together, then wages would fall to a Nash equilibrium of the certainty equivalent. Would be the direction of the wage change. Yeah. All right, let's get at least a start on this one. So number 4, we've got models. Blow this thing up here a little bit. In the model management industry, firms supply human models for advertisements. Models may vary in skin color, which is measured on a line unit length. Skin color can be modified with makeup, and makeup costs are incurred by the firm. Each firm enters the market at an address on the color line, and each firm manages 2 models. Suppose the cost of an extreme makeover, the cost of going from one end of the color line to the other, is $90. Illustrate the determination of makeup costs in a city with 4 models, and then 4 models of 2 firms in a city with 6 models, 3 firms, including the values from the makeup per model. All right, so this is asking you to kind of follow. I'll pull it up on my thing too. Let me just go back to this thing. So the line is from 0 to 1. So what was the extreme makeover going to cost us? 90 to move from 0 to 1. So if you located here, it would cost you $90. So then just do the same thing we looked at here: 4 laborers, 2 firms; 6 laborers, 3 firms, and figure out the calculation of the cost.
Do you need
Of
to
the
have
gap.
that since we have the formula?
You can use the formula too, yeah. So we have the formula. Let me go back to this section on here.
Was the first one 3 firms?
4 firms, 2 laborers,
Or it was 4 laborers, 2 firms,
4 laborers.
6 laborers, 3 firms. So it's the same as in your transaction.
Yeah, same as this.
Yeah.
This is question 4 on the book.
Chapter 4, right?
And I've got mine pulled up now so I can flip back like I was just doing it. So here's the question again. $90, determination of makeup cost in the city, 4 models, 2 firms, 6 models, 3 firms. I'm going to flip you back to this. It's a pretty easy problem once you get it. He just wants to kind of force that you go back. So with the skills gap, what do you guys get? And then what Luke was saying was this is our formula. And that's just the gap. So that's the calculation of the mismatch.
So then, would the scale be 0 to 1 or 0 to 90? It's $90 to.
It's still 0 to 1. So it's on the same 0 to 1. It's just normalized to 0 to 1. Yeah. That's part of the model, is just thinking about it being from 0 to 1.
When they do dividing by 6, what is, and then 10, what is it for?
Well, that's just a result of conceptually what was going on here with there's your 2 firms on the location, and we had the 4 models at different ends, and so there was a skills gap of 1/6 and a skills gap of 1/10, and that comes from this formula. The mismatch is the gap.
Given that M, how would you do that?
No, given the n. So you got 1 over 2 times n minus 1. And then the question, illustrate the determination of makeup costs in a city. So including the values for the makeup cost per model. So what do you guys come up with that?
I don't understand the question. Like, illustrate the determination of makeup costs. Like, what the hell does that mean?
So what was it in the example we went through? What was the cost? What was the training cost? 30 if you went from 0 to 1. So same thing with the extreme makeover. We're going from 0 to 1 is now a monetary cost of 90.
It's going to be like 1/6.
So now at the gap, you're just basically applying exactly what we did here. 1/6, 30 divided by 6 is 5. So it's just 1/6 of 30. It's 1/6 given this thing, given the way these terms are.
So if I could,
So let's just do an example of what if it was, what if n was 10? What's the mismatch?
would be
So m equals 1 over 2 times 10 minus 1
over 18.
1/18. So as the n goes up, the gap goes down, and what happens to the cost then for the makeup cost?
Down.
It's going to go down.
Yeah.
So now it'd be 1/18 times 90.
So for our case, it's 1 over 6 times 90. And then for the first one, for the
Yeah, 1/6 and 1/10.
That's the answer.
Same numbers, yeah. Same numbers. So easy, but yet so difficult.
It's so easy, but like the brain is small.
Yeah, sometimes it can, you might have to struggle with it, but you're kind of going back and just applying a different case. What it does is, this is kind of a complicated model, but it forces you to just go back and look things over.
So.
1/6.
That's just a given.